All right. Good morning, afternoon, evening, night, wherever you happen to be. It's good to see you guys on another Null News. We're going to spend just a little time talking again. I need a stream starting so that people have time to gather. It's the news. I don't like just jumping right into it. All right. How's everyone doing? How is everyone doing? We have quite the agenda to cover today. Everything from the clouds, but Kubernetes 127 is coming out. I'm going to still make a release video. I know that they don't get the most views, only a couple hundred, but it seems like those people really do like them. When I mentioned maybe not doing them, they very much said that they liked them a lot. So I'll probably go ahead and make that video, but you guys are getting the bleeding edge. All right. I guess to fill the time while we're waiting, I can tell you guys one reason I haven't been even working on a video this week. Haven't even worked on the next video. I mean, I have been working on animations, but my NLE, the thing I edit my video in, wouldn't launch for me. And you know why it wouldn't launch? This right here is the reason it wouldn't launch. My brother-in-law needed a new GPU, so I got him a A77 Zero because it was like the most affordable bang for buck. And I was like, on the conditions, well, I mean, I was getting it for him, so I tested it on my machine for sure. It's better than my 2070. It's better than my 2070, except every single NLE I tried to use, from DaVinci to Premiere Pro to everything, failed to launch because I had to go into Windows logs and everything, and it failed to launch because they kept trying to load CUDA, and I uninstalled them, reinstalled them, reset their settings, everything, and they'd still fail on loading CUDA. So I never could get it to work for that. So I'm not getting a 77, an A77, but it was better than my 2070 on games. So that's nice. But it seems like I'm going to skip a GPU upgrade this time. So, anyways, I guess that's probably enough time, giving time for people to filter in. It's good to see you all. All right, let's start with security. I really only have one thing for security, and that is this right here. Let's see. This run right here. There was a leak. Now I was looking to see if there was any new updates, but I couldn't find any. But there was a pretty big leak with Ukrainian information on like strength, and as well as like their burn rate of rockets. The only thing I found is that the U.S. did say that these looked like legitimate reports, but as far as I know, it hasn't come out on how they were leaked. So we don't know if this was a hack by, Beijing or Russian intelligence or sponsored hackers, or if it was like the good old Snowden walked out with a thumb drive type of leak. So I will try to figure out. Next week I'll report on it some more, and if there's any more like new news on it, I'll let you guys know. My guess is that I don't have a guess. I don't have a guess. So, anyways, But yeah, so far they're looking into it. So I know as much as now. That doesn't mean the federal government, you're, uh, it doesn't mean that they don't know. The NSA doesn't know. It just means that they haven't released why. And thus I don't know. Anyways, that's it for security. Do you guys see anything else for security? Yeah. Do you guys see anything else for security? Okay. Well, then we're going to jump right into our cloud news. Yeah. Gonna jump right into the cloud news. There was only a couple things that I saw in the cloud, so we'll go through them really quickly because I'd like to keep as much time for Kubernetes 127 as possible. And yeah, so let's jump through these. All right, so AWS supply chain is now generally available. This is something we've talked about in the past. If you are dealing with supply chain, it's definitely something you might want to check out. But it's now generally available, which means generally, again, when AWS makes something generally available, they give you some guarantees, an SLA, before it's in general availability. They either have a much reduced SLA or no SLA at all. Although a lot of the times it's just like a 2.9s SLA, like they have one, just not very good when they're in beta. When they're in private alpha, no SLA usually. That's at least been my experience. Another thing when it goes GA is it generally is more available in different regions. So definitely, if it wasn't available in the regions you were concerned with, it definitely is probably in many more regions at this point. Nice DVC announces the general availability of the DCV extension SDK. Now, if you don't know what nice DCV, I don't know why I want to put the V first. It's easier to say that way. It is the deliver high performance remote desktop application streaming. So it's your desktop streaming. Anyways, there is an extension SDK. So if you're wanting to write an extension for that, it is now generally available. Amazon Elastic Cache can now be added in front of your Amazon RDS database in the RDS console. So this is kind of cool because, a pretty classic use of a cache is to sit in front of a database. And they're making it easier now by letting you set this right in front of it, right here. Now, I would be interested to see how or if anything has changed in things like Terraform and their CloudFront templates, because if they made that also easier, that would be really cool. Although I didn't actually see anything directly about that. So, part of that will be, does Terraform support it, and or CloudFormation templates lag a little bit as well. And it's possible that there's no new API. It's just something that they did in the front end to enable that. So really, there might not be anything that has actually changed. But this is a nice change anyways, because it's a common use pattern. So it's nice to see common use patterns being made simpler. All right. Amazon Lambda introduces a response payload streaming. So if you are trying to stream, I guess this is pretty self-explanatory if this is your use case. So Amazon Lambda is their serverless. It's their Lambda functions, whatever you want to call them. Anyways, it can now progressively stream responses payloads back to the client, including payloads larger than 6 megabytes, which is actually pretty cool and something that is pretty unique. The over 6 megabytes. I don't know about Azure. I don't know Azure very well, but I know that GCP has a limit. I don't know if it's 6. I feel like it's more than 6 megabytes, but there is a payload limit to it. Now, that being said, they don't discuss their limit. Like, can you do a gigabyte? I don't know that you would want to do a gigabyte, but can you? I don't know. So, yeah. It's good to see you all. Thanks for joining. Okay. Last one. Amazon Aurora now supports Postgres 15. So if you were using Postgres, it's now supporting 15.2. So Good. Let's jump on to Google. All right. So of the week of April 3 through 7, they're just like business days. Sorry. Anyways, I was like, it's the 9th, but whatever. One of the things that I saw that I think is the biggest is Google Cloud Deploy now supports Canary releases as a development strategy. This is in preview, so we can go. You can go look at it. But it's allowing you to basically, with their Cloud Deploy, make 2 separate types of deployment so that you can test things. This wasn't supported previously, so it's good to see if you're using Cloud Deploy. It's good to see that this option exists now. So go check it out and give it a check. That's what I usually say. It's not the right words, but it's what I usually say. All right. Another one, this one I found a little bit interesting. I don't quite understand it. I read it a couple of times and read through some of the stuff. You can see the purple links. Was trying to I didn't find a good article on this specifically, but Cloud Run services as backends to internal HTTPS load balancers and regional. So basically, you can run Cloud Run as a service as backends to internal and regional HTTP load balancers. So basically, this is allowing you to establish private connections between Cloud Run services and other services and clients on Google Cloud. Now it says on-premise or other clouds, which confused me because this is where like I needed to understand it a little bit better. I'm not sure I'm getting the big picture here, but this contradicts internal HTTPS. The top part, but I'm wondering if it's like in conjunction with Anthos or something like that. So again, that's why I wanted to read a little bit more on it, but I didn't find anything solid. I will give you this link. It was a pretty good overview, but yeah. Anyways, so go read it. I don't quite understand this part, but anyways, the premise of it sounds pretty good, allowing you to use Cloud Run as an internal service to connect to other services. So the general base idea is pretty simple. I just didn't understand all of it. All right, and then we have the identity-aware proxy and the external load balancer overview. And then, wait, no, I need to go back to here. The data stream, we talked about this one previously. The data stream for BigQuery is generally available. So we talked about it when it was in beta, I believe. So this is actually pretty cool, and I'm glad that it moved pretty quickly. It actually only seems like it was in beta for like a month, honestly. But BigStream for BigQuery is generally available. This is really basically allowing you to stream your data straight into BigQuery to get that business intelligence, that BI data almost as fast as possible. So if you're using BigQuery, this is pretty cool, and I think a pretty cool technology. So yeah, give it a check too. All right. This one, defend against DDoS attacks with Azure DDoS IP protection. So there was some updates to their DDoS protection. I know I love Cloudflare for their DDoS protection that you can get for absolutely free. But I think Azure has. I feel like I've never used Azure's, but I feel like theirs is like second best, maybe tied for second. I feel like it's pretty good. AWS also has a fantastic WAF. I've never heard bad things about GCPs. So maybe all 3 of the major ones are kind of tied for that second place as far as their WAFs go. So anyways, it's good to see they released some new improvements to the IP protection, and you can read about them more here. I do want to get to the Kubernetes stuff, or we might go over more of each one of these. But yeah, so I'll release this. It's actually a decent article. I'll put that into chat. There you go. The general availability of read replicas for Azure Database for Postgres Flexible Service. So this is just giving you the ability to have read replicas of Postgres. Pretty simple. It's nice to have. This can basically reduce contention on your database if you're wanting to have high read throughputs, and but you're still wanting to write a bunch to like a more central database. So it can be a scaling thing, or allowing you to deploy it to an edge and get it a little bit closer. So there's a bunch of things you can do with this. Be careful of the costs, though. These things are expensive. Support for VMs using Ultra disks in Azure Backup. I have no idea for this, but I did find this also awesome because there are such a thing as Ultra disks, which is just amazing. Next, we'll come up with Uber disks, but Ultra disks enable customers to run mission critical I/O demanding enterprise application on cloud, including applications like SAP and HANA. So UltraDisk are just enabling backup on UltraDisk is currently available in select regions. So, yeah, pretty awesome. And that's it. I know I kind of rushed through everything because I really wanted to get to Kubernetes. Now, I tried to get I tried to get ChatGPT to make my Kubernetes 127 video for me, and it just would not. I tried to convince it to do this for me and tell me the best things. It kept saying it's not been released. It gets released in 2 days. Tuesday is when it gets released. It gets released in 2 days. So then it first tried to tell me about 126, and then it told me like things I could look for in an upcoming release generically. So we're gonna have to do this the old-fashioned way. Now, if you don't know, this right here has the release schedule for you. So yeah, here's the release schedule. And you can see that, let's see, the release here happens on Tuesday, the 11th of April, 2023. So, again, 2 days. 2 days. So let's go over all of the different enhancements, features, releases. Now, this time around, there were 60 of them. 60. That's up from last time. I think there was 38 last one. Now, for all of you wondering, in my release videos, I complain that everybody reports a different number. This is how I obtain my number. I go to the 127 enhancement tracking document. I remove the status of removed from milestone and deferred, and it gives me my number of enhancements. That is literally how I do it. There is no magic. That's the number I use. We can look through here, see which SIGs and stuff. This is actually a pretty cool document. Whether it's tracked, which milestone it is, and this one, the type right here, I specifically like because you can then, another thing that I do for my videos is like I filter on net new, and we just look at the net new ones. So actually, I think that's how we'll do this section. We'll just go first on net new. We'll look through all of them and see which ones are interesting. Now, I'm going to read through them all first. I'll pick out the ones that I find most interesting. If you please let me know in chat the ones that you would like to also see if they're outside of that. Yeah, we'll do it. Now, I've already read through some of them, but, you know, yeah, we'll go through. So these are all the net new, enhancements. So let me actually, I had a bunch of them open, but I'm going to actually get rid of all of my open tabs for this. All the ones that I thought the first read through. All right. Oh, another useful thing here is this deprecation guide. I don't think the 127 one is out yet. Here we go, 127. Hey, Russell, how are you doing? So there's your deprecations. And if you guys are trying to find this, this has these filters already in there. So this is for the net new. We can actually remove the net new if you guys would like, but let's go over them. Switching between this and Rocket League, no problem. No problem. I get it. I get it. Go watch Rocket League. I'm probably gonna still make a video. I wanted to do this part live as well, so people can tell me their ideas of what's most important, and we can have conversations on it. So I'm doing it live, but yeah, definitely go watch that Rocket League. All right, so we have cloud dual stack IP node IP handling, improve the kubectl plugin resolution for non-shadowing. Shadowing what? I can't read the rest of this. I don't like these. All right, we'll have to for non-shadowing subcommands. Okay. Oh dear, I clicked something. Let's go back. There we go. We'll also have to open this one to read it. Redesign and graduation strategy. So the kubectl apply prune, redesign, and graduations. I'm going to pull this one up. I also want this one here. All right, elastic index jobs. Seems like an interesting word choice. Allow informers for getting a stream of data. We have to open it just to see what they're saying instead of chunking. So this is, do you guys know what the informers are? Maybe this is a good thing for a video. I feel like not enough people know about these informers. So we're going to leave this one open just so we can talk about informers for a little bit. Reserve node port ranges for dynamic and static out. This is really not net new. They've been working on this. Like there might be a net new feature about it, but it's not really net new. Oh, hey everyone! For everybody that just joined, we are going through the Kubernetes release notes. We already talked about the cloud news. We already talked about security. If you had something you wanted to bring up in that, please go ahead and bring it up. We can switch back to it, but Kubernetes 127 is coming out Tuesday. I will make a video on it. It will be a couple of weeks before that video is out, though. And so this is kind of like the pre-release party, and we're doing it live. So is there a feature that you're excited about? Let me know. We're going to cover all of them. Right now, we're covering the net new features. So we'll go over things that are graduating. These are all the things that are new. All right. Kubelet limit for parallel image pools. Okay, I mean that makes sense. Pretty self-explanatory too. Robust. How much CPU will be able to use with Kubernetes 127? I don't quite understand the question. Informers, aren't those reliable versions of watchers? Yeah, kind of. I would say probably better all around. They can do some stuff that watchers can't either. In place for update for pod resources. I need to understand what pod resources they're talking about better. Kept for adding webhook hosting capability to CC. What is this? What is the CCM framework? There's so many abbreviations. It's very hard for me to keep track of them. KEP is Kubernetes Enhancement Proposal. What is the CCM? Oh, the Cloud Controller Manager. Okay. All right. So this is kept. We'll read more about it in a second. I think that might actually be important. So the CCM, the cloud controller, is the thing that interfaces between the clouds. It basically allows, you know how you can define a load balancer. Load balancer is the perfect example. A load balancer then actually spins something up in the cloud. That's what the CCM does. It's that thing that interfaces with your cloud and tells it how to do stuff. Let's see. Can I make this? I cannot. Okay. Kept for adding webhook. Okay. Extend pod resources to include resources from dynamic resource allocation. Okay. Not too exciting. Support user namespaces in stateless pods. I feel like this isn't net new. I feel like, again, like some of the ones we talked about above, is there's been a lot of work in this. And sometimes it's hard because like it's probably a net new functionality in this space, but it's still with the progress of what they're trying to get done. So we'll look at that really quickly. Multiple service. We're gonna check this one out because I actually know this person. I could email them. So I always like to keep up with my friends' work on these things so that if I ever whenever I do talk to them, I'll be able to talk about, hey, that was a nice feature. All right. Remove transient node practices. Predicates, not practices. Publishing Kubernetes packages on Kubernetes or community infrastructure. This is probably a big one we need to cover. We have talked about it. Actually, if you look up, not here, but in the deprecations, you'll get a big red warning. I love how the warning goes away when you scroll down. Oh, actually, pretty cool though. It's something to know about. So basically, the old ones that are hosted on Google are going away. It's something that I brought up in my videos on Kubernetes. Oh, how much CPU? I didn't think about the Discord chat. Sorry. And I'm sorry, I didn't mean to be like super harsh on articles. I've gotten a little bit more harsh on articles, I think, because some of them really dropped the ball on maybe what I would call my standard of entry for. Yeah, but I probably should be less harsh. It's nice that people share results. I just like results to be meaningful sometimes. That was too harsh too. I didn't mean it that way. I don't know what they mean by dynamic resource allocation. Okay, so I think those, I right clicked on all the ones I found interesting, or I needed to know more information to know if they were interesting. Did you guys see anything else here that you would like to see? 16 net new. That's pretty good. You know what I am going to do though, while we're going through this, what we're going to do, one second, cone of silence. I just want to make sure I don't leak anything. I'm not going to say whether I have a tendency of leaking things online or not. All right, we're going to start this doc right here. And anytime that we find something really interesting, we're going to just post a link to it. This is what I normally do anyways. So you guys are helping me make my video. My address is not safe with you guys. Not at all. Not at all. All right. Dynamic resource allocation. One thing that you guys do have to understand, if you click from here, if you click on this actually will take you to a tracking issue. So anything that you click from here will take you to a tracking issue. From that tracking issue is usually a link to the KEP. That's how I navigate this. The KEP is usually more interesting to me than, I mean, the tracking is important. It tracks what what release it's going for, if it's tracked for it. It's going to also list any updates and different KEPs that are responsible for it, and some discussion if you're interested in more. For the most part, for my videos, this is enough digging into it. Although I have jumped into the discussion some just to make sure. But yeah, anyways. All right, this is for the dynamic resource allocation summary. Users are increasingly deploying Kubernetes as management solution for new workloads, batch processing, and new. You know what? I actually would say batch processing is one thing Kubernetes has lost hard to Nomad. Nomad, I have heard, does batch processing really well. I haven't used Nomad for batch processing, which is what I've heard. And in edge computing, such workloads no longer need just RAM and CPU, but also access to specialized hardware. Yes. So you're all what they're talking about specialized hardware is you're talking about your GPUs, FPGAs, specialized disks, and things like that. With upcoming enhancements of beta data center interconnects, accelerators can be installed outside of specific nodes and connected to nodes dynamically as needed. Okay, this isn't net new. This isn't net new. We discussed this in 126, right? Let's go back to the tracking doc. Let's see. Status net new. I wonder if something has updated to it. Because this was it removed from last release? So this is the thing is I feel like sometimes things get yanked at the last second, and so if you take your notes too early, it could be wrong. I'll need to look into this one more. I'm going to leave this one open. We're going to leave a note here. Was all right. So yeah, basically what this one is doing is allowing you to dynamically add stuff. Wow, was my example good or what? For example, FPGAs. Yeah, nailed it. All right. All right. I'm excited. I got that one. All right. Support user namespace in stateless pods. Let's check out the cap. Summary. Here we go. This is a fantastic summary. This is a fantastic summary. All right. Let's dig into it. So when they refer to user namespaces here, they are actually talking about namespaces in Linux. Now, we talked about this in 126, but it wasn't stateless pods then. So I do believe this is net new, although this is one of those things that is highly related to the work done in 126. The goal of supporting user namespaces in Kubernetes is to be able to run processes in pods with the default user. So basically, what user namespaces are allowing you to do is let me put this. This is a good one to talk about in the video. User namespaces are going to allow you to user namespaces are basically going to let you run something as admin without actually having admin to the node. So anything that's looking for a privilege, like you have things like databases who want to run privileged, they can now run privileged, and they'll run in the user namespace, which means that they still don't have access to the system. That's what's happening here, and that's why it's pretty. A pretty big deal. It's pretty important. It's good. This guy's a fantastic guy. Very brilliant. I got to work with him a little bit at SUSE. Yeah, cool guy. Learned a lot. Learned a lot about networking from him. He's fantastic at networking. All right, motivation services. Let's see. Allow to dynamically expand the number of IP addresses available for services. this is really good. A lot of the times when you built a service and you made your service IP CIDR, it was locked into that. And so if you really wanted to expand the number of services as your things grow, um, this is was unable to you were unable to do that. So this is really powerful. It's going to allow you to grow your cluster without rebuilding it. It is effectively what this is going to do. Now, let me see. I feel like work on this has also been done in 127. I'm going to have to check my notes. Again, it's probably that it was something else, but that this narrowed it down or added some specific support that wasn't worked on last one time. Remove transient node predicates from KCCM. What is this? Is Kubernetes Cloud Controller Manager? No, it's the CCM, which is the. We'll have to go check it out. I have tried to stop using abbreviations. Kubernetes Cloud Controller. I called it. The service controller in the Kubernetes Cloud currently adds, removes nodes from the load balancers, nodes set in the following cases. When a node gets the taint to be deleted by cluster autoscaler, added, removed, when the node goes ready or not ready. Okay, so this is the cloud controller manager, and so basically this is actually what I was talking about a little bit earlier, is that this controls the Kubernetes load balancers, and I guess they call it the Kubernetes Cloud Controller Manager instead of just Cloud Controller Manager. So you can abbreviate it KCCM or just CCM. Fantastic. Anyways, so basically, again, it's controlling that load balancer, and really it could control more than just load balancers. But this is when it gives you you add a node, that node actually has to be added to the load balancer in the cloud, whatever cloud that you're working on. And so let's see. However, only applies to services with external traffic policy cluster. In both cases, removing the node in question from the load balancer's node set will cause all connections in that node to get terminated instantly. This can be considered a bug, suboptimal behavior in the nodes which are experiencing transient readiness state, or for terminating nodes, since connections are not allowed to drain in those cases. Even though the load balancer might support that, moreover, on large clusters with a lot of nodes and entropy, resyncing load balancers like this can lead to... Oh, okay. Okay, so basically what this is doing is helping with the resyncing of load balancers. But how does it do that? As to enable connection draining, reduce cloud provider API calls, and simplify the KCCM's sync loop, this KEP proposes that the service controller stop synchronizing the load balancer nodes sets in these cases. Seeing as how this has already been the case, a new feature gate stable load balancer node set will be introduced, which will be used to enable the more optimal behavior. Okay, so they're just optimizing the behavior here. I think that's worthy. I don't think it's going to be something that people actually experience. This is something that your cloud provider is going to implement. So it's not something that you are as a user. And I try to state those in these where it's like, this is a good thing, but really it's your cloud provider. If you use a GCP cluster, they're going to have this configuration and set it up. It would only affect people that are running kubeadm in the cloud, which I feel like the people that are running kubeadm are usually on bare metal. So that's something I like to call out. Probably only helps people or affects people running kubeadm. Or, I mean, if you provide Kubernetes as a service, this is something you should be aware of, as it can help, help thrashing of your load balancers. Publishing Kubernetes packages on community infrastructure. Okay, so we already talked about this. I don't know where it is, but yeah. Basically, the community now owns the infrastructure. There is a redirect. When that redirect fails, I don't know when that's going away. I will make sure to bring this up, though. We'll talk about that. That's a good one to talk about. In place of update of pod resources. Have no idea which pod resources they're talking about. Let's find out. This proposal aims at allowing pod resources requests and limits to be updated in place. Oh, okay. Without a need to restart the pod or its containers. Okay, I think this makes sense. I don't think this is the biggest deal ever, but we'll talk. We'll bring it up. So basically, you don't have to restart your pod when you're updating its resource limits. When they said in place updating pod resources, I thought like, oh, is that disk or things like that? But that's not what they're talking about. They're talking about their CPU memory for example. Okay. Cool. Now we are using CCM instead of KCCM. We know though. All right. This one is also about the CCM, the Cloud Controller Manager. This step will detail enhancing the CCM framework to support cloud provider specific webhooks. The intent is to make it easy to either generate a binary or enhance the existing CCM library to host such webhooks. We also intend to allow for easy linking in standard webhooks needed by other SIGs, which need to be. I don't understand what this is doing. Like obviously I understand that they're making a webhook, but I don't understand why and what benefit it brings. The CCM is the binary in which the cloud provider places all the controllers needed to make Kubernetes cluster work correctly in their cloud. Again, yes, I've already covered that. There are also occasions where it makes sense for a cloud provider to want these customizations to be able to be applied synchronously during API service request handling rather than asynchronously after a change has already been applied. Our initial example of this is from the SIG storage. These would like the functionality from persistent volume label, admission controller. This needs to be completed for cloud provider extraction to complete. Several cloud providers have indicated that this should be done inline, especially as the existing deprecated solution is implemented in the API admission plugins, which is inline in the request path. Oh. Okay, so I think I understand. I'm going to have to read this a little bit more in depth, but if I understand from this motivation and goals here, what they're trying to do here is basically, maybe I need a doc to draw. Basically, there was a mission controller for the persistent volumes, the persistent volume labels, and what they're trying to do here is the persistent volume labels are being removed, and they're wanting to add that functionality into the CCM. And to do that, they need a webhook for basically a CCM admission controller, basically allowing them to basically have a webhook where a payload can be sent if it matches the admission, the standard admission controller pattern. That would be my understanding right now. I'm going to have to dig into this one more. So I'm going to put this one in the what the crap category. This is my category of ones that I need to investigate more over my initial review. To whether even to know if they're important or even to give a good idea of what they're trying to do. Cloud dual stack node IP. Okay, so this is IPv6 for sure. Let's read. Allow administrators of clusters using external cloud providers to override the cloud selected node IPs in a more dual stack aware manner. I don't know why this is hyphened. Dual stack aware, is that like a thing? I don't know. Allow administrators to override. Okay, so yeah, this is just IPv4, IPv6. I'll bring it up because I think it's important for the people that actually have to support this. This IPv4, IPv6 is a pain in the derriere. I don't like dual stacks, one or the other. Elastic index jobs. This one's interesting. Let's see the cap. Are you guys liking this? Do we like the live review of the Kubernetes release? Is this what we want? Are you not entertained? I can't really say that. I don't feel like I have. Wait. Oh, here. Let's jump over to the files. Let's open. Let's see. There's the YAML. Oh, here's the README. View file. Bam. All right. Currently, spec.completions is an immutable field in job for both index and non-index modes. This kept proposals allow mutating completions for index jobs if spec.completion equals spec.parallelism before and after the update, meaning that spec.completion is mutable only in tandem with spec.parallelism. So basically, if this is mutable, then completion should be mutable. There are cases where a batch workload requires an auto-scaled index. There are cases where a batch workload requires an auto-scaled index job with stable DNS pod names. For example, MPI, Hoovered, Ray, PyTorch, etc. Oh. Oh, this is interesting. Sorry, I had to take a little second to wrap my head around it. And I'm definitely going to have to think more on it. Because as I was reading this, I was like, this sounds like a stateful set. Why? This sounds exactly like what you would want with a stateful set. And then it comes down here and it's like, while such workloads could be modeled as stateful sets. I was like, okay, yeah, that's exactly what I was thinking. The job API is a better fit because it offers batch-specific features such as allowing indexes to run to completion and pod and okay. So basically, this is trying to bring my understanding. I'm going to bring this in the what the crap category. It definitely will make the video. I say definitely. I'm fairly positive it will make the video. But my current understanding is this is bringing stateful set abilities to the pod or to the job batch handling. I think that this is probably not the biggest deal for a lot of people, but I do know things like PyTorch. I don't know these two. Should I know these two? I don't know that I know these two. Should I know these two? 1 second. Let me see what this is. Oh, okay. This is machine learning too. All of these are the machine learning. They're like PyTorch. Okay. Okay. So that's cool. Allow informers for getting a stream of data instead of chunking. Sounds pretty self-explanatory. I'm more interested in the motivation here. Like, who is this going to help the most? I also like it when the link takes me actually to the README instead of me finding the README. I can find the files if I wanted them. Do we not have a README here? Oh, it's right here. Allow informers for getting... yeah, because like sometimes you can read that and like, yeah, it makes sense what they're doing, but why do they want to do that? Especially for my videos, I like to figure out why so that I can help people understand how it's going to affect them more. Like, how does this affect somebody? I don't know off the top of my head. The Kube API server is vulnerable to memory. Ooh. Memory explosion is never good. The issue is apparent in larger clusters. where only a few list requests might cause serious disruption. Uncontrolled and unbounded memory consumption of the servers does not only affect. Hey, remember that article that we were talking about earlier? Remember that article? Does not affect the clusters that operate in. One second. Uncontrolled and unbounded memory consumption of the servers does not only affect clusters that operate in HA mode, but also other programs that share the same machine. In this cap, we propose a potential solution to this issue. Oh, I think I'm starting to understand. Today, informers are the primary source of list requests. The list is used to get consistent snapshot of data to bring up to client side in-memory cache. What they're also probably talking about here is what is it called? Custom resources and operators and those types of things. I mean, that's where a lot of people use their informers. Are you guys liking this? Nobody's saying whether they like it or not. So hopefully that doesn't mean you all just left. I will take that as you don't like going over these. Again, this was kind of like, I will do the video as well because enough people complained that I said I was probably not going to do the video and I'll just do it live. So there'll be a video too. Hope you watch it. Oh, that just... All right. That was not the best drink I've ever taken. All right. Today's informers are a primary source of list requests. The lists are used in a consistent snapshot. Blah, blah, blah. Yeah, okay. In extreme cases, the server can allocate. I've never actually seen this. I'd like to better understand why this could happen. We don't have to dig into that today. I would like to know. This actually sounds like people that will affect people that run really large clusters more than anything. So this is the gigabytes of the API server. 2 informers, 4. Man, that can get out of hand. 9 gigs. At 16 informers, the node was lost. Oh, okay, sorry. Another reason that you shouldn't run workloads on your control plane nodes. Oh, cool. They also put the test. Maybe this is something we should look at testing, see if we can't replicate it. This has been something. This is the classical problem. What is this? The name for this is metastate stable errors, which I actually need to make a video on metastate stable errors. It's a pretty cool one. But you guys all know what they are. If you don't know the terminology, metastate stable. Metastate stable errors are where, you know, the stable state after an error is error. And so basically what they mean by that is, let's say that your service can, for simple terms, can handle 10 requests per second. But if you try to do 11 requests per second, it has some sort of error. And once you hit that error, you could go back to 5 requests per second, but you'd still be in an error state. Like a lot of times metastate stable errors require you to restart everything or come up in a very careful specific way, or, you know, a lot of other things. That's what a metastate stable, again, I need to make a video on that. And basically this is kind of a metastate stable error state, is what they're saying under some circumstances. So we'll definitely talk about that one. I already put that one in there. Double dipping. All right. Okay. Apply set, prune, redesign. Let's see what this is. I believe I've seen this. At least talk about it. With creating objects with the kubectl apply, it is frequently desired to make changes to the config that remove objects and then reapply them and have those objects deleted. Since Kubernetes wants an alpha stage prune flag exists to support this workflow. I didn't know this. Did anybody else know that the prune flag existed? Did anybody know this? I didn't. Cyberplex, thank you so much for the follow. I just want to tell you that stream is pretty new, and we are working on some fantastic Twitch alerts that are going to be completely custom through AI, generative AI. I work on those on the other days that I stream. I do the news today. Anyways, you'll get a completely custom thank you message when that system is finally done and actually working. And it kind of works now, but it doesn't actually show on screen. So anyways, thanks for the follow. Did anybody know that this existed? This is definitely going into the news. Or into the video. My goodness. Every initial implementation has fundamental design flaws. That's 100% true of everything I write. Okay, cool. So it looks like they're updating this. Cool, cool. Awesome. Did not know that existed. All right. So that was all the net news stuff. Awesome. Awesome, awesome, awesome. Let's look at the deprecations. Ugh. The V127 release will stop serving the following deprecated API versions. Storage V1 Beta 1 is going away. Of the CIS storage capacity will no longer be served in V127. All right. So this is pretty standard. When the V1 is released, which I do believe V1 was released two sets ago, and it's deprecated, you get 2 cycles. So that makes sense. It was 124. They extended that 1 cycle. They didn't have to because it's only 3, right? Yeah. All existing persistent objects are accessible via the new API. No notable changes. Cool. Cool, cool. All right. Let's look at... We have net new here. Let's remove that. Actually, I hate this where I can't just remove net new, but I can come up here and URL hack the net new off. Yep. Like, I can remove everything or net new, but I wanted remove per milestone and deferred still. Let's see. Which other ones are we? Graduating, net new. Let's look at filter by values. Let's see. Major change. There is 1 major change. All right. Ooh, this is one we've covered, so this is good. The retriable and non-retriable pod failures is again a thing that we've talked about in 126, but this looks like there was a major change that was made to it. Let me remove major change again. They need to fix this. I don't want a URL hack. All right. And we can look at graduate. We won't cover graduating in the stream. Graduating is just really going over. I'll go over the big ones that are graduating to stable in the video, but there's no reason for us to spend too much time looking at those. I don't think. Let's see. Excluded type, graduating deprecation. We'll cover. Let's check out deprecation. We already looked at those. Cool. All right. Let's look at this retriable and non-retriable failures for jobs. Let's find out what the major change was. Let's see. This is where it takes a little bit more investigative journalism on my part to actually figure out, because this just links the tracking document, and so we're gonna have to dig in to find out what the major change is. We'll put this in our what the crap section. Um, sometimes you can go here. No, they don't have any extra data. That was not recently. That is not recently. Neither of these were the major change. There's too many of these to look through today. I'll figure this out. You'll get it in the video. All right, so that's that was live Kubernetes. Now I still have the rest of my show to go. Maybe I should have done Kubernetes at the end, but the rest is all about just some stuff I saw in the open source community, some announcements, and some articles. And then at the very end, I have a 16 system design article that I haven't read that I thought I would react with you guys. So yeah, maybe next time I'll do the Kubernetes part at the very end. What do you guys think? Did you guys like it? Let me know how you liked doing the Kubernetes release notes right in line. I know it's a good half hour. And thank you for helping me with the video. All right. Let's get on with the news. So, Wayland 122 was released. Look at this. That's awesome. As soon as we can find a GPU that supports it, I will switch. Wayland is way better. It's just way better. The X server has been garbage for a long time, but everything supports it. So we still all use X. So, woo. All right, community forks. I don't cover GitLab a lot, and I feel a little bit bad because they're pretty cool. I don't use them though, so it's a little bit hard for me to cover. Now, it seems like it was very hard for people to be part of the GitLab community, because it seems like outside contributors couldn't actually make contributions to the core repository. They had to make and keep their own copy of it, which meant that they had to use their own CI/CD minutes in GitLab of the GitLab fork, which meant it was also expensive for them to contribute to the GitLab code. So it seemed like it was a mess, but if you were wanting to be part of the GitLab community, they came out with community fork. So basically, they're maintaining a fork of GitLab that the community can contribute to. Now, I'd be interested. This sounds like a mess, because it sounds like they now have two main forks, and are they going to merge in that community fork to the main one every once in a while? I don't know. It was interesting. Having a community can be difficult, and there's a lot of ways to do it wrong. I don't know if this is a good way or a bad way. I'd love to see, I'd love to hear from them in the future. Lee Ticket, I'd love to hear from you in the future of how well this has gone in 6 months, and let me know. Is this a good way? Is it a bad way? We'll find out. All right. Have you guys wanted to code at the speed of light? Well, you might want to switch to Dvorak, but there is a new code editor. Now, I don't know what everybody's problem with Vim and Visual Studio Code is, but everybody hates it. So Zed has been released. I don't know. I haven't downloaded the beta yet. I tried Fleet, the the thing that was released from what's their faces, the other popular code editing group. I didn't like Fleet very much. I was gonna make a video on it, but then I didn't really like it very much, and so I didn't want to make a video on. Fleet was from JetBrains. Thank you. And I know that JetBrains makes a lot of fantastic IDEs that I mostly don't use. But I really didn't like Fleet a whole lot. So I didn't make a video. I don't like making videos of being like, I really didn't like it very much. Maybe I needed to come up with like a way to make it a little bit more motivational where I talk about the things I don't like, but I say some of the really cool things. It was pretty lightweight, ran fast. Is Zed the new Ed? Zed is from the people who made that is from the people who made the thing that VS Code replaced. What is that? GitHub made their own, and then when Microsoft bought them, they basically sunset the project that GitHub made. They're the people that made that project, but I don't remember it off the top of my head. Atom. They made Atom. Thank you. They're from the creators of Atom. Atom, not Atom. Atom. Um, the one cool thing that they seem to be doing, and they'll talk about. I love how they like talk about CRDTs, like they're revolutionary and they haven't been around for 20 years. But the cool thing is, it looks like they tried to support remote multi-workers at the same time. So I actually like this. Visual Studio Code has a plugin for this that works pretty well. I believe that there's actually a NeoVim plugin that you can do this with. But basically, you can invite people to work with you. And if you're needing to rubber duck or whatnot in a, well, not rubber duck specifically, but like if you're having a problem and want to share it with somebody, of course you can join, a Zoom call and share your screen. But it's actually better to join a Zoom call without screen sharing and actually just go through the code with them. JetBrains has their own version of that works pretty well. I used their Go IDE for a little bit that works pretty well. I've done it in Visual Studio Code. I haven't done it in NeoVim yet, but I do believe there is a plugin for that. Anyways, this is built into Zed. So that's cool. I'd like to see that. I think it's a good feature, especially for remote engineering teams. Moving on, the hardware we need for our cloud exit has arrived. I covered this a while ago. You know what? Let me post Zed in there too, just in case you guys want to find it and are too lazy to Google. So 37 Signals is moving away from the cloud. And they got all their hardware, and he talks about it a little bit. They go on to list all of the different stuff that they have, all the new servers that they got. I cannot make this picture. I can make this picture bigger, so I just lied. But basically, these new ones are the KVM machines that they got. So they were already running stuff in a data center. I'm sure it's a shared colo. They have 4 racks here. And it looks like they got 1, 2, 3, 4, 3, 3, 4. So it looks like, they got, wait, this would be 9, this would be 8. So yeah, 17 new servers. These are pretty big, beefy servers, but it looks like these bottom ones here, let's see, these 2 and these 2 and these 2, yeah. That's beefy. 48 cores. That is nice. They have 7 terabytes of RAM. All right. So anyways, this is cool. And actually, I think this is something we're going to see more companies do in the future, to be honest. Clouds look quite boxy in real life. Yeah. I'm very interested in following them because I actually think that we're going to see a paradigm shift, maybe in the next 5 years, over the next 5 years, in how people leverage the clouds. And I think like tools like Kubernetes are going to help leverage that. And you're going to see, Kubernetes and Istio. Istio is hard to manage, and I'm not even saying to use it for a service mesh, but you can use it to make a secure tunnel between your clouds and things like that. And so you can have it that east to west networking through it. But I think you're going to see even more of that type of stuff that comes out and lets you use the clouds in a different way for like spillover and things like that. Clouds look quite. I like that. That something like with clouds look quite boxy in real life should be a shirt. ChatGPT clone for just $300. I thought that this was you're going to have to pay $300 for it, but it looks like a team has fine-tuned developing. I have no idea how to pronounce that. Which is an open source to ChatGPT 4, which reportedly achieves 90% of ChatGPT's quality and costs the training model was around $300. It costs them $300 to train it, which is actually pretty good. The model was a fine-tune using Llama, and that's pretty cool. So, anyways, you can download the model. They made the code, the model weights have all been made public. So that's pretty cool. We're probably going to be running our own ChatGPT eventually in the future. It's probably going to be next year before I get to it, but we'll see. If I think that compute is headed back in-house, do you think a new wave of infra engineering consultancies will grow? I've always had this problem with consultancies. I've always thought, hey, I'll become a consultant to fix the problem with consultants. But I don't know. It's like I generally have a problem with consultancies. And probably, I would agree with you that probably would happen. I think also you're going to see the tooling. Well, management consultants are just dumb. But I mean, like, just what do you mean by infra engineering consultancies? You mean like teams that will help you set up your infrastructure, or do you mean like people that will run your infrastructure for you and give you a private cloud? Because I think the latter has some real possibilities. I struggle with consultants in general. Right. Okay. So for that, I agree with you. I don't see companies wanting to keep op engineers on 24/7. I think easily that, yes. And I wouldn't have my own statements about that because I see a lot of like software project management consultancies where they'll come in and help you write your app. And in general, I think it's a waste of money. But if you're saying like, hey, I have 6 data centers and we'll run your ops for you. Absolutely. I think that's a great business plan. Because not only do you, I mean, it's almost like Rackspace 2.0. That's what I would see it as, Rackspace 2.0. I could be wrong, but and I don't think you're going to see. I still think the cloud is going to pay. I don't mean that you're going to see a huge like leaving of the cloud, but I think that people are going to use it a little bit differently. So I think for your startups, 100% still 100% the cloud. It has a cost, and I think everybody can agree that it has that cost. I mean, that's how they make their money, is obviously they're charging you more than what it costs them to pay the engineers to design the software at large scale, and more than it costs to buy and maintain and run the hardware. Obviously, it costs them less. But, but for small teams that want to act rapidly, that don't want to have to worry about those things and don't want to have to worry about a large scale outage that could happen if done improperly, 100% you stay on 100% cloud. I think what you'll see is in the medium and large businesses where they start prioritizing their data center and multi-cloud things, where they are going to be able to they have enough business that they're going to if you said that you could hire an engineer and save yourself $1,000 a year on your cloud, it doesn't make sense. That engineer costs way more than than $50,000. It doesn't matter at that point, and so you shouldn't do it. But when you're starting to get large enough, you can do it, and it makes a lot of sense. And I think that's where we're going to see the shift: is these larger companies, these larger or medium-sized ones, are going to be able to reap enough benefit from, even if it's just shifting some ancillary things off. Right. You'd reach a point where a successful company is paying too much for the cloud. They're the ones ripe for running their own infra. That's I guess what I'm trying to say. Is is I think as a startup or small business, you want to 100% stay to the cloud, because that's just where it makes sense. You're not going to reap the rewards of doing anything else, anything yourself. But there's going to be a point, and I don't know exactly what that point is. I can't tell you the cloud spend. Once you spend $1 million a year, then it makes sense. I don't know, and it probably is dependent on people, because like if you use Kubernetes, I actually think it's easier. But if you don't use Kubernetes and you're using like Elastic Beanstalk in AWS, it may be a lot more work, and that's where, yeah, I don't know exactly, but I do think you'll see that shift coming up in the next couple of years. Something that came out of nowhere, was completely silent, some might say, popped up on my radar this week. Silent, the fast and easy UI toolkit. All right, so before this, we really only had one universal UI toolkit, which was I can't remember its name. Anyways, I just saw this. I'm gonna post this in chat. It comes It comes. Its licensing is interesting. If you want to release your software under GPL v3, you can use it as GPL v3. The full thing. There is no licensing restriction. There's no like you don't get enterprise features. You get everything. But your code, because this is a copyleft, has to be GPL v3 compliant. Okay? That's actually pretty cool for open source projects. I haven't used it. Again, it just popped up this week. But the cool thing is it does support WebAssembly. I don't know. That seemed interesting. Go give it a check if you'd like open source UI stuff. Oh, I suppose it's not silent. Is it? Man, I made a whole pun for just me being stupidly bad at reading. It's slint. Slint. You know what? Silly British. It's silent. You just spell silent wrong. I'm just going to go with that. I'm going to own it. I meant it. What do you know about English? I'm American. My goodness, I'm horrible at reading. My goodness, let's move on. Let's move on. Reading, not my forte. Okay, anyways. It's pretty cool. One of the things I wanted to point out is like they had a demo where it's running with no OS, which I think is pretty cool because like this could be a really cool thing for drivers. Oh, no, no, no. I only read, so I don't know how things are pronounced, but you're 100% right that it's 100% not silent. I'm just really bad at reading. Um so anyways, yeah, if you have an open source application and are looking for like a UI to a little application that you can run on like an embedded device, I think this is really cool. I'm kind of excited about it. I have some embedded devices that don't have UIs, but maybe I could make some that actually have a UI. I don't know. But yeah, it also works on Windows, Linux. That they had a whole bunch of supported platforms. So you know, oh, it's also made in Rust, which is cool. Um, and uh, and they support Rust, which is also cool. So yeah. Anyways, I thought it was nice. No, no, just don't worry. I'm just really bad at reading. Cosmic DE first spring update. So Cosmic is a desktop I've wanted to try for a little while. It sounds like it's designed for developers, and I haven't been able to get my fingers on it, and they're still not letting me get my fingers on it, which is really thoroughly annoying. I was thinking this spring update was going to be the update where I could get my fingers on it. Still can't get it. Carl, I guess, is using it as a daily driver, but doesn't think it's good enough for people to get their fingers on. So, what I am excited about it is that it supports tiling and a full desktop. So, I use i3 because I like tiling, but it doesn't really have a full desktop. It doesn't do volume, it doesn't do those types of things. You can program some stuff around it, but it doesn't handle all of that type of stuff. So, anyways, I'm excited about it, but come on, Carl. Let the rest of us have it. All right, Buck 2. I know that we've been on this, like, is Rust popular enough? And it every single time we see some another large tech company releasing something in Rust. So, Facebook released Buck 2, which is faster than Buck, which isn't open source. So it's kind of weird for you to compare it to something that nobody else can use. But Buck 2 is faster than Buck. If you've got nothing to do, Buck 2 is significantly faster, which I think just means that Buck must waste resources if I'm reading it properly. But if you got lots to do, Buck 2 will start doing it faster and be much closer to the critical path. Don't even know what that means. But I'm excited because Facebook actually has been kind of on a tear of releasing some open source recently. Buck 2 is out there. It's also written in Rust, which is fantastic, although it does have Starlark and Erlang and Python in here. But don't fear, those are actually just examples because I guess how you interface with Rust is in Starlark. So it's interesting. I know that we've had a conversation about Starlark versus Lua. I think we're going with Lua, but there was an argument about it. Um, so they obviously went with Starlark. Yeah. Anyways, it's cool. It's cool to see this come out. I don't know that these big build systems are that large scale build tools are that useful anymore. I feel like you're having a good CI/CD pipeline is much better. You can use these things in their CI/CD pipelines, although I'm just not sure the value that they bring anymore. I know that some large companies have them and still use them, but I'd be interested in what you guys think. This would be like on I almost said Gradle, but I don't mean Gradle. What is Google's? Google has one, Bazel. This would be like Google's Bazel. Again, they can be used, and I think that there are some use cases of them, but yeah. All right. I know it's been long, but we have one last thing. If you guys want to go over it with me, I have an article. You guys can recommend an article to go over to end this off with. If you would like to recommend an article, you can do it in Discord or you could do it in chat. but I will find one just in case nobody has a recommendation. I don't read it ahead of time, and I try to find one that we can have a good conversation about and talk about. So this one seemed interesting. Haven't read it yet, but it is 16 system design concepts I wish I knew before interviewing. I thought that would be pretty good. So I'm going to go across it. Let me know what you guys like. Also, did you guys like going over the Kubernetes release notes? Let me know if you did or didn't. I know I keep asking, but nobody's telling me anything. All right. 16 system design concepts I wish I knew before interviewing. Mastering system design interview, essential concepts for every software engineer. This looks like a good picture, a load balancer, some API gateway, notification server, CDN. It has everything. A block server, metadata server, a cache. Okay, well, fair enough. Fair enough. Um, search result aggregator. Okay, so yeah, a lot of stuff here. Some queues. Some more queues. I wonder what type of queues they are. They almost look like they're Kafka channels here, but yep, Rocket League is more important, for sure. To excel in system design, one of the most critical aspects is to develop a deep understanding of fundamental system design concepts such as load balancing, caching, partitioning, replication, databases, and proxies. I agree. Um, Although there's also the security implications, which I didn't see in here, like the simple security, like TLS and some things like that as well, that I would expect in a system design. Through my own experiences, I've identified 6 key concepts that can make a significant difference in your ability to tackle system design. Another thing I don't see in here is like event. They have queues and they have a notification system, but it doesn't seem like these things are in an event. Like, how do they communicate together? I'd like to understand your system design and how your whole system communicates together and why you pick that. You could tell me a monolith because I didn't tell you that it wasn't two people, and that was the best thing for two people to do. As long as you can defend it, that's what I'm asking for. Do you know why you pick the things that you do? If you say microservices, but then can't defend why you would pick microservices, that's an absolute failure of a interview. System design interviews are unstructured by nature during the interview. Yep, it's difficult to keep track of things and be sure that you have touched upon all of the essential aspects of design. To simplify the process, I have developed a system design master template that should guide you in answering. One second. Is this something you can buy? Oh no, it's just. Hmm. We'll go on. Keeping this, we'll discuss 16 essential system design concepts here. Maybe this guy does different system design than I do. Domain name systems. What does he mean that you need to know about DNS? We'll have to read a little bit more. This seems like a weird one. Does he mean how DNS works or how internal DNS you're going to do? I guess. I don't think that I've ever talked much about that or had somebody talk about it. Microservices that everyone wants to work on them. Yeah. And sometimes you pick a technology because it's easier to find people to work on it. And I think that's an acceptable thing. Like, do you use Go or Rust for your microservices? I would say in general, Go is easier to find a developer to work on the service. Um, so maybe that's the choice of why you use Go for the microservice. Um, yeah, developer availability is an actual design decision, 100%. You could make the argument that we would use Java because we have 12 Java developers that we can go get right now, and we can make the system. And like, how am I going to argue? It's much harder to find good Go developers than it is to find a good Java developer. I'm not advocating for that, obviously. But yes, resource availability is 100% one of those things. Domain name system is a fundamental component of the internet infrastructure that translates human-friendly domain names into their corresponding IP address that functions like a phone book for the internet. Who doesn't know this? This is like basic information. My mother knows this, and she doesn't even know how to use a computer. When you enter a domain name into your web browser, so he's not even talking about like internal DNS. Like this isn't even interesting. Okay, that's not even interesting. Let's move on. I don't know, like, yes, you need to know this for, but I don't even know how it would come up in a system design because I would assume that you know. Yes, I'm not advocating for the Java develop. I'm just saying like everything you can my point was that you can argue everything based off of resource or something. If you argue microservices for me to me, tell me why we should be doing it. And if you understand why, hey, I expect these services to have a lot of load, or this service has special scaling that needs to be separated from everything else. You can spell out to me why you make a choice. We don't have to agree on it. You're proving that you understand the reason, the right reason to make a choice. Not that that is, in this hypothetical scenario, the right choice. Um, all right, a load balancer is a networking device for software that distributes incoming. I feel like all of this is really, really basic. Do we need to go over this? If you're in a system design, I expect this to be, I don't know. Maybe I'm wrong, but like this is okay. So understanding how load balancers work, the round robin, least connection, IP hash, all of these. This is good, and this is covered. Like what strategies are you going to use? This makes sense. Not just what load balancers do. Okay, I think this is very good. You need to have a solid understanding of load balancers going into something. What problems they solve, and whatnot. You've now not only insulted Java developers, but Haskell and developers. You want to throw COBOL under the bus while you're at it? I'm not stopping you. An API gateway is a server or service that acts as an intermediary between external clients and internal microservices or API backed. I don't know how I feel about API gateways. I think that you should understand API gateways. It is a critical component in modern architectures, especially in microservice-based systems. That is fair. That's fair. Um, and it's important to understand if you're going with microservices why you need an API. So if you say like you're building a microservice-based system, you need some way to expose that system and understanding how it simplifies the communication I'm going to say simplifies the communication process and provides a single point of entry into your services. Um, so you realize that Java developers plus 7 developers is half the developers in the world plus 7. Think on that. The main functions of an API gateway include request routing, authentication, and authorization, rate limiting and throttling, caching. Yeah, fair enough. They don't all have to be handled by your API gateway. You can handle these in API gateways if you like. Also, not all API gateways support all of these things. Rate limiting and throttling is an interesting one, for sure. All right, a CDN, a content delivery. All of these things are very basic. It's a distributed network of servers that store and deliver content such as images, videos, style sheets, and scripts. Blah, blah, blah. Yep. Here's how they work. When a user connects content from a website or application, they request is directed to the nearest CDN server, also known as an edge server. Yes, if the edge server has the requested content cached, it directly serves the content to you. And most of your clouds have CDNs already. So, like, if you make a website, you can pretty much just register it, deploy it to their CDN, and it all just works beautifully and naturally without you having to do anything. It retrieves it from the origin server or another CDN server nearby. Yep. Yeah. I don't think that I mean, I think understanding CDN servers at this high level is good. Everybody should understand them. How these edge servers work. I mean, you can deploy your own CDN, and you don't have to use the cloud's provided one, especially if you want to do something fancy at the edge. Um, Especially if you're doing something fancy like machine learning at the edge, you have to do your own. And how you do that probably is outside of my standard one. Yeah, how you deliver that edge content can be kind of complicated, but forward proxy versus reverse proxy. I would argue that there is no difference from a forward proxy versus a reverse proxy, except whether it's inside of your network or outside. Like if it's proxying stuff into your network or proxying stuff inside of your network. Otherwise, they function the exact same. It's just kind of where they sit. A forward proxy, also known as a proxy server or simply proxy, is a server that sits in front of one or more client machines and acts as an intermediary between the clients and the internet. When a client That would be a reverse proxy. When a client machine makes a request to the resource on the internet, the request is first sent to the forward proxy. The forward proxy then forwards the request to the internet and perhaps cloud, and then they return. A reverse proxy is a server that sits in front of one or more web servers and acts as an intermediary between the web server and the internet. When a client makes a request to a resource on the internet, the request is first sent to the reverse proxy. Again, I would say, like, I don't know that this is that important, and I think that this is splitting hairs. I never called it a forward proxy. I generally just call them both proxies. It's just, what are you proxying? Like, which direction are you proxying? They're saying a forward proxy proxies it out to the internet, and a reverse proxy is taking it from the internet to the services. It's just which direction. They're doing the same thing. A reverse proxy sits in front of the one or more web server, and that's intermediate between the web servers and the internet. When a client makes a request to a resource on the internet, it request is first sent through the reverse proxy, then forwards the request onto the web servers, which returns the response to the reverse proxy. The reverse proxy then returns. No, it doesn't. That's actually a really good point, and actually probably a really good point for the CDN as well. Is security, and this is where when I do a systems design interview, I want to know why you would have this reverse proxy, and one of them is security. There's some stuff in the API gateway, if you're using an API gateway for security. There's also reasons to use a reverse proxy as well. So I think that's a really good point. Why are you using a reverse proxy? Don't tell me. Another really good thing is, don't say I'll use a reverse proxy here, because my next question will always be why. Why would you put it could be the right thing to do. I'm still going to say why. Oh wait, they might have a little here. Yeah, server anonymity, caching, load balancing, DDoS protection, canary experiment, URL, content rewriting. Okay. You can also do those in your API gateway. But yeah, there's a lot of overlap in a lot of things. I wouldn't do canary experimentation at the reverse proxy. Maybe that's just me. You could. You could. I just probably wouldn't. Caching, yep, absolutely, 100%. You need to know caching very well. Why you would cache, why you wouldn't cache. Probably the biggest thing. If you just say, I'll use a database, I'm going to immediately ask you, what happens if that database becomes slow and unresponsive? How might I speed it up? That should immediately make you think caching, but there's also a lot of other things that you can cache. So if I'm asking you about caching, tell me about like a CDN, which is just a really good cache on the edge, because that's just caching static files. You can cache everything. You can even cache a specific API. So you can't just tell me to use caching. You need to tell me why to use cache. I'm not sure it'd be caching in the reverse proxy. I agree with that too. The cache is a high-speed storage layer that sits between the application and the original source of data, such as a database or a file system or remote web service. I'm just saying, don't think of a cache just as in front of a database. It can be in front of anything. That's all my point is. And I would expect you to know that too. When data is requested by application, I'd also expect you to know why you wouldn't want to cache. Like frequently invalidated data. When the data is requested by the applicant, first checked in the cache. If the data is in the cache, it is returned to the application. If the data is not found in the cache, it is retrieved from the original source, stored in the cache for future use, and returned to the application. In a distributed system, caching can be done in multiple places. An example, client, DNS, CDN, load balancer. I would not cache in the load balancer or the API gateway. These are gross. CDN is a cache, so like saying you could cache in the CDN seems wrong because a CDN is just a cache. You can cache on the server, that feels wrong too. Don't cache when you hate your users and want to make them wait long for the same data. Another use to frustrate your users. Database shouldn't be caching either. You should cache in front of these things. I don't like this at all. Let's see. Client cache, use cache, faster retrieval, DNS cache. I mean, so your computer caches DNS. Did you know that? Not only does your computer cache DNS, so does Firefox cache DNS. A lot of things, they can cache a lot. There's a lot of caching in a lot of places for DNS. Lots of things. So yeah, expect to understand a lot about caching. Another thing that they didn't go into here, but like caching strategies. I want to know caching strategies. When you say, okay, I'm going to put a cache in front of this database, well, explain to me how you're going to invalidate records. Is it and tell me different ways of invalidating cache and why you would pick which way you would invalidate it. Again, you can't just say, I'm going to put a cache in front of it. Tell me why. And when you tell me why, I'm going to ask you questions on why that solves that problem. You need to know those. You can't just say caching. And please, CDN is a cache. And don't cache. If he's saying you can cache in front of your load balancer, that seems a little sketchy. But you could. I guess that's kind of a CDN. Data partitioning. In databases... I don't know. I don't really cover this. In databases, horizontal partitioning, known as sharding, involves dividing the rows of a table into smaller tables and storing them on different servers or database instances. This is done to distribute the load of a database across multiple servers and improve performance. On the other hand, vertical partitioning involves dividing the columns of a table into separate tables. This is done to reduce the number of columns in a table and to improve the performance of queries that only access a small number of columns. I don't understand what he's going with here. I don't know that this is that big for a system design. And the reason is I would be more interested personally in you telling me why you picked a certain type of database. How that database scales and how you can scale it is ancillary to the initial problem. Every single database can be scaled. Absolutely. To terabytes of data. Absolutely. I'm talking Postgres. I'm talking MySQL. Can be. Now, how painful it is to scale, that's a whole different one, and really comes down to your familiarity of a certain database technology. So, vertical partitioning is a SQL type of partitioning. This sharding here is also generally a SQL type of thing. Although some, like MongoDB, actually do use vertical share, but it all depends on which database you're picking and your familiarity with that database on whether you need this. For example, Aerospike doesn't have any of this. It does actually some very automatic partitioning itself, but there's nothing for you to know. Um, yeah, so, but yeah, how you shard a database is very much up to the database. I wouldn't expect you to know how to shard a X database in an interview. If I said, how are you going to scale it? And you can be like, well, Postgres, I know shards. Okay, that's fine. I don't know need to know more than that. Vertical partitioning. I don't actually, it's not denormalization, and I don't actually like vertical partitioning very much. But basically, it's where it's done more in column based instead of row based. But you can do it in row based as well. So column based are your big data warehouses, like your Snowflake centers and whatnot. But you can partition the table into chunks effectively. Denormalization would kind of be the opposite, yes. And you know, it's great if you say, and here's another thing. Here's another thing on interviews for system design. If you bring it up, I expect you to know what and why and where. So if you bring up denormalization, I am specifically going to start to ask you questions about denormalization. If you don't know denormalization very well, don't bring it up. And you know, it's fine. I might be like, hey, would denormalization work? And you could be like, hey, I think it would, but I'm not very good at denormalization, or I haven't done it very much because I've only really worked with SQL databases or whatnot. And that's completely fine. But if you say, I would for sure here use denormalization, I'm going to ask you why you would use denormalization there. Then I'm going to ask you the consequences of using denormalization there, because I expect you to expand on why you pick that. And if you pick that technology and that solution, you should know all of those. You should know the costs. Denormalization means you're going to have data in more places. It means that you're going to have to make sure that you synchronize data in more places if it changes. There are some things you can do to mitigate those risks too, and I would ask you about them. Data denormalization isn't really, though, partitioning, data partitioning. It's more about no SQL databases tend to have a problem with many-to-many relationships, and sometimes one-to-many relationship or many-to-one relationships. And data denormalization helps with that many-to-one relationship problem. Right. I want to make the query faster, and I don't want to do absolutely. You don't want to do a join. If you don't want to join, you do data denormalization. That's how you what it does. You copy the data to extra places. It's easy, but it also causes its own problems. Database replication is a technology used to maintain multiple copies of the same database across different servers or location. Again, I don't like this just because it changes with different databases. Now, if he's talking about database replication as a whole, I don't know. There's a lot of reasons to replicate a database. It can be disaster recovery, but again, specific ways in how it's done. Like Aerospike, you can do, Aerospike is a database that's pretty fantastic. But how you replicate that data is done in a much different way. If you want to have, so we support many ways to replicate your data across different Aerospike databases, but it's highly us. Like we do it our own way, and each way has that same sort of thing. And we have our own patterns that we support, and there's trade-offs to all of them. I don't know that I ever expect in a system design to for you to know my Postgres's way of database replication. Now, if you want to get into why you might do that, then great. You can talk about high availability. You know, you have a warm standby. Basically, you have one that's ready to go right as well. Improved performance, I think, is a trap. I think it is a trap, and it's an expensive trap. If you're doing this for improved performance, a cache is usually way better at database improved performance than a replica. And this is a really expensive trap. I would highly recommend against this. The only case is if you're doing a small amount of data and you're wanting it at the edge, maybe. I think that this is a trap most of the time. Enhanced data protection is pretty much the same as high availability, so this is the same as part 2. Load balancing's So basically, what you give up with 4 and what he's not saying, and what I would ask you if you said this was handling more load distribution. When does the cache become a read replica? Isn't the cache a read replica? I mean, the idea of a good cache is that you're caching a small amount of data that's highly effective. So it depends on how much you're caching. Absolutely. That's what I was going to say. Not everything is cacheable, because if every query is new, it doesn't matter. But a lot of times you can look at the patterns of your database access and you can find stuff that is easy to cache. A lot of the times. Now, obviously, sometimes there's very unique. And that's why I said a lot of times I thought that this was a very expensive trap. Not all the time. But I think if you're doing this, you should look at caching first. Because I think a lot of the times this is a trap. Not always. I will acquiesce to that. It's not always. But, like the real goal of caching is if you can find 20% of your queries that you can cache that are 80% of your load, you have a huge win. And a lot of times people have that. A lot of the times. Distributed message systems. This is huge. If you said microservices, you better know distributed messaging systems. Distributed messaging systems enable the exchange of message between multiple potentially geographically sparse application services components in a reliable, scalable, and fault-tolerant manner. They facilitate communicating by decoupling the sender and receiver components, allowing them to evolve and operate independently. Distributed messaging systems also are particularly useful in large-scale and complex systems, such as those found in microservice architecture. Okay, examples of these are Kafka and RabbitMQ. I think of read replicas being used for analytics on a DB that is primarily. Okay, that's actually a good one. That's a good one. I stand corrected. That's a fantastic one. So what I think Russell is bringing up here as a really fantastic use case here is when you have a BI, business intelligence or whatever, that wants to query a database, but you don't want them to query the production database because it will slow down that for your consumers that could be writing or even reading. It's fantastic to have a read replica for them. So basically, they can do whatever they like, and they're not messing with it. Now, that's not for. I mean, technically, I guess that is improved performance, but there's actually more reasons than that. It's not just improved performance. It's the fact that your BI team can't delete your production database. They can't negatively impact it. They can't change the, they could put their own index on this that works better for them, or things like that you don't want them to be doing in their production. So I think that's a fantastic reason. So a good call out. This is why I thought this was a good one to go over together, because there's a lot of stuff that people's different backgrounds could call out. With this distributed messaging system here, something I want you to call out is, just because you use Kafka and RabbitMQ doesn't mean you decoupled everything. A really important thing here is schema. Your messages should be schemaed. That way, I actually really like protobuffers. Because protobuffers lets you schema and version them, and you can actually basically, especially if you do the schema correctly, everything's backwards compatible, or could be, and you can basically then do it based off of that schema, so you can read the right messages. I think that JSON is horrible in Kafka or RabbitMQ, and if you've ever used it, you would know that. So you don't want something that's schemaless. You want something that has a strong schema in your message passing. Microservices are architectural style in which applications are constructed as a collection of small, loosely coupled, and independently deployable service. Each microservice. This is actually a really good definition of it. Microservices that are structured in a collection of small, loosely coupled, as uncoupled, undecoupled, or as decoupled as possible, and independently deployable services. Each microservice is responsible for a specific piece of functionality or domain within the application and communicates with other microservices through a well-defined API. It really should communicate with other services through Kafka. This approach is a departure from the traditional monolithic application, where an application is built as a single, tightly coupled unit. The main characteristics are microservices are single responsibility, independence, decentralized, communication. Is REST lightweight? I don't think so. Or message queues. Really should focus on message queues. I'm going to ask you why as well. Why you pick the way they communicate. Be ready to defend that. I think that's really important. I'd argue against fault tolerance, but monoliths are easy to make fault tolerant. No SQL databases. You know what? And maybe I'm different in this. When I'm doing a system design interview, if you've had no experience with NoSQL, but a lot with SQL, that's fine. I don't hold that against you. If you come in and say, hey, I've never touched NoSQL in my life before, but this is how I would do it with an SQL and why I would do these things, and understand those, you don't have to know every part. You should know enough to make a system yourself. You can't have a major hole. You can't say I've never used databases. But if you use NoSQL or SQL, one or the other, I think that's fine. And I guess it depends on what you're applying for. This is not true. Designed to store and retrieve unstructured, semi-structured, semi-true. Do you consider vector databases to be a NoSQL? Most do. What about graph databases? Most do. Those are all NoSQL. They usually retrieve structured data. They offer an alternative to traditional databases. That is generally true. You just insulted my entire job. Thank you, Russell. Which rely on structured data and predefined schemas. Again, I really like how Martin Klapman made this in his book, Designing Data-Intensive Applications. NoSQL versus SQL really comes down to who owns the schema. And it's usually like, does the database enforce the schema? If so, that's usually the SQL. And we could also say the transaction, the transaction. But Or does the application enforce the schema? There is a schema, so it's not schemaless. It's that the application is responsible for the schema, not the database. I would disagree with these. Well, first he forgot vector. So there's a fifth one here. Column family, I really feel like the column is really your warehousing. I feel like that's a separate one. It doesn't really your database warehouses, one, have been around for a while, and I don't really feel like when I say no SQL, I'm generally talking about your document, key value, graph, vertex base. Not really column, but maybe column. I guess Cassandra, yeah. Maybe I stand corrected on that one. But there's at least a fifth. Database indexes are data structures that improve. Okay, yeah, I would expect you to understand database indexes. This is really simple, though. I feel like these are really, really simple. Yeah. So vector databases are something to do with ML. I actually think that vector databases will have more uses outside of ML. I actually think a vector database would be a cool way to try to do. I think so. A vector database tries to store data in a way that related items are stored close to each other. Now, coming up with a good relation is a good way of understanding the problems with vector databases, and like they're not super popular out there right yet. ML uses them a lot, or has started to. I think that they could also be done for stuff like recommendation engines. I think that vector databases could be really useful for that. I've been That's another video I wanted to make because I don't think that people use or understand vector databases very well. But I think that they could be really big, or really important, or really useful in niches. I find NoSQL databases to be more niche databases. They fill a very specific use, and then they start to be less useful outside of that use, that niche. And I'm not even saying the niche is like a small little thing, like machine learning. Vector database is really useful. They start to be less useful the further away. Graph databases are really useful, but they have a very specific set that they're actually really useful for. So yeah, there's some venture capital around vector DBs. Yep. That is true. Distributed file. Oh, Ceph. If you're not an expert in Ceph and can't tell me the steps to set up Ceph, I don't even want to start the conversation. That's a joke. Ceph is notoriously hard to set up. Yeah, probably. I mean, the research into vector DBs and ML probably. Although a lot of your big ones, you don't need a vector DB. Distributed file systems. Distributed file systems are storage solutions designed to manage and provide access to files and directories across multiple servers, nodes, or machines, often distributed over a network. If you have multiple servers, nodes, or machines, how else are they distributed? Like, how else do they communicate? I think often is a bad keyword here. They're always over a network. They enable users and applications to I guess you could say that they're all on VMs, but then they're not really distributed and they're not really over a network either. Maybe they hit the NIC, but they don't if they're done well. Torrents. I guess, yes. But I think you're also talking about your Cephs here. I don't know how much you need to know about this. Um, S3 would be a distributed file system. How much you need to know about how they work probably is not that important, but I would expect you to know why you might use a distributed file system and how you would leverage it. Yep. Notification systems, these are used to send. He needs more than this. Yes, but why would you use one? It's not just for text. Notification systems are things that you can notify, even to somebody using a web app. They're super powerful. They're kind of difficult to implement as well. So I would want to know how your notification system would work. How are you doing this? Are you using webhooks? Or not webhooks? I'm sorry. WebSockets. Are you using WebSockets? How would you do WebSockets with a microservice system? Those are the questions I'm going to ask you right away, because this is hard. It's a hard problem. Maybe you know of an easier solution. I'd love to hear it. That's not a monolith. I'd love to hear that too. Full text search. Full text search enables users to search for specific words or phrases within an app or website. Okay, don't really care. These seem like I needed to get to 16. Yeah, there's some databases and caching things that you can do for full text search. Does he mean that you know inverted indexes or Elasticsearch? Again, I don't know. It's probably good to know why you might use Elasticsearch, but I don't know that it's that important to know about inverted indexes. Well, yes, full text search is useful. I'm not arguing that. I'm just asking, like, what is he saying that I need to know in my design system interview about full text search? Is it that I could implement it with Elasticsearch? I think that's probably the most important thing. Is it why an inverted index is useful there? I don't know. Even I could only tell you the beginning part of why an inverted index is really powerful there, or quick. I mean, it enables it to do it semi quickly. But yeah, I don't know. What else do you want? As far as the system design goes, I'm trying to think of what in a system design I would be asking about in full text search. I'm not even sure that full text search has come up in, not in my system design interviews. Distributed coordination service. Distributed coordination system are system designed to manage and coordinate the activities of distributed activities, applications, services, or nodes in a reliable, efficient, and fault-tolerant manner. They help maintain consistency, handle distributed synchronization, and manage the configuration of state in various components in distributed environments. Is he talking about like etcd, or what is it? Kafka uses Zookeeper, although they're moving off of Zookeeper. There's some others. I think HashiCorp has their own. But he's just talking about another database. This is a NoSQL database. This is a freaking Raft protocol here. Is that? I would think that he's more talking about like Kubernetes or something like that. Let's continue reading. Or nodes in a reliable, efficient, and fault tolerant. They help maintain consistency and handle distributed synchronization and manage configuration and state. This is Kubernetes, maybe? Nomad? Distributed coordination services are particularly useful in large-scale or complex systems such as those found in microservices and architectures, distributed computing environments, or clustered databases. Examples of services are Apache, Zookeeper, Etsy. Okay, I got Zookeeper and etcd. I forgot Console. That is, but that doesn't even. If the company is dealing with large data like books or papers, then I can see why it's important to talk about full text search. Yes, I agree. Why wouldn't he call this orchestration? And if it's orchestration, it's not Zookeeper, etcd, and console. I mean, don't get me wrong. Nomad uses Raft as well as Kubernetes uses Raft, and Zookeeper uses Raft. But yeah, this is a weird way to say this. And distributed coordination services, yeah, orchestration. There's several orchestration, whether it's Nomad, Kubernetes. I would expect if you pick microservices, you need to know how you want to coordinate those services. 100%. You can't run Kubernetes and Nomad, and those came out of a need from a microservices to coordinate the distribution of your application and your software. So 100% you need to know this. If you pick microservices up here, this is predicated on this. If you didn't pick microservices, you don't need to know this. Although I would expect you to still know it at a high level. And understand what importance they need. I don't know about these here. These are databases. etcd is a database. It's a NoSQL key value stored database that gives strong consistency guarantees using Raft. That's how it does it. That's how it makes sure that there's not a network partition. Some other things that aren't on here that I would want to understand in your distributed system here is like etcd. You brought up etcd. What does etcd solve? Well, etcd uses Raft to handle consensus. And so it's a strong consistency database. And how it provides that and what Raft provides, well, let's talk about network partition of fault tolerance. Let's talk about the CAP theorem. Do you know the CAP theorem? Because you better know the CAP theorem. Because, yeah, it's important. It's not a particularly great database. etcd is not a particularly great database. It solves a single problem. And honestly, if there was any database, I think that you should switch out Aerospike for. If you're using etcd, I think Aerospike just does it better. I really, really do. I really, really do. This is the one where we stomp etcd and Redis. Redis and etcd are just sucky Aerospikes. That's my super biased opinion. Like, super biased opinion. I can't tell you how biased I am. But if you wanted to say, like, one thing that we just do better, it's etcd and Redis. But I'm super biased, so. Actually, these are some things I want to do on stream sometime. Maybe they're like week-long things where we actually design these services and deploy them. I've actually wanted to do these because I think these would be fun. Wait, what a minute? Waiting a minute? I'm waiting a minute. I'll give you exactly 60 seconds. We're at 50 seconds. Gossip Gloomers. Gloomers? Yeah, Gossip Gloomers. A series of distributed system challenges brought to you by... What? Our first challenge is more of a getting started guide to getting the hang of working with Maelstrom in Go. In Maelstrom, we create a node, which is a binary that receives JSON messages from standard in, send JSON message to standard out. You can find a full protocol specification in the Maelstrom project. We've created Maelstrom Go library, which provides maelstrom.node that handles all of this boilerplate for you. It lets you register handler functions with each message type similar to Okay. Is this just like a set of challenges? This will be put on the to-do list. Well, we might do these on whenever I have the time. I think this looks really cool. Implement a globally unique ID generation system. Oh, so these are like system design. These are hard. Yeah. Yeah, these like designing a URL shortening service or web crawler. Yeah, I like these. Preliminary broadcast system that gossips message. Okay. Ooh, actually, the swim protocol is a pretty good gossip protocol to implement. These are cool. Implement a replicated log service similar to Kafka. Has it never seen the Null DB? I think this is actually a really good one. These are different than these system design. These are a different style of system design, but these are definitely good design challenges. These are more. These are more like what a distributed database deals with. Like these are distributed database system designs. These are a little low level. Okay, these are lower level than these. These are higher level. These are very much things at a low level distributed system design that you need to know. These over here are things like a video streaming platform or URL shortening. These are at a high level how I would use a system that implements some of these low levels. I think both are actually really, really good. You know, design Twitter or Facebook Messenger. Like, what are you going to do? How are you going to connect? And what technologies are you going to use? And what are your backends going to be? These are more whiteboarding. Although I think that we could actually do some demo apps, like actually design some of these services eventually, maybe next year, where we actually design some of these to run on the Null cloud. They not all of them would be very hard, and we can do them in different languages. Some of these would be a lot faster if I used Go instead of Rust, but these are actually really good too because I already know a protocol like Swim. Well, actually, that would be a multi-node, a little bit better than a single node broadcast. Um, these are actually really, really good. I thanks for bringing these up. These are lower level. These are low level system design. These are if you went to work at a database company, the system design questions they're going to ask. These are the design questions that a company that creates a web app is going to ask. Awesome. I need to get going. This has been fantastic and fun. I hope everybody enjoyed it. Thank you so much for sticking around. For those of you that did, I appreciate all of you, and hopefully you guys like this. Do you guys like the article at the end? I do. I like the conversations we've had. I think that it's all pretty good. Oh, Russell, I think you missed it. I have given up on the ARC 7700. I gave it a try. Long story short. My brother-in-law needed a new GPU, and so I got him one, and I got him that one. But since I was pieing it, I decided that I got to use it for a week first. Because it's like the only appropriately, somewhat reasonably priced GPU out on the market right now. It worked much better than my 2070. So as far as my 2070 goes versus this, it was better. The few games that I played, it played the games better. It did everything pretty much better than my 2077, except for I couldn't get DaVinci Resolve to work with it. Could not. This entire week, I tried to get DaVinci Resolve to work with it. Could not get DaVinci Resolve to work with it. I uninstalled it, deleted all the app data, deleted all the configurations. So then I had to when I reinstalled DaVinci Resolve, I had to reset it up, and I set it up without the things, and it would just crash. Should be around the 3060. I think it's the best value. Like if I was looking for a GPU, I think I would recommend people get the Intel Arc. I was super happy with it. Other than that, and obviously I got it for my brother-in-law, so I wasn't gonna keep it around anyways. Other than that, yeah, it was really good. For the price and for the size, the other GPUs have just gotten monstrous. Like I could use them as a self-defense weapon. Maybe even more than self-defense. You chuck that thing at somebody and it could do some serious damage. I did. I got the. I did get the. I got him the best arc that there was. I did. Um, it was fairly cheap, so it has the 16 gigs instead of the 30, or instead of 8 or 10 gigs, or was it 18 gigs instead of 6? I don't remember. I got the one with the more the 7070, the 770 with the more memory. Um, I don't know why I couldn't get my NLEs, my video editing, to work with it though. It was super frustrating. Yeah, uh, I'm super happy with it for $350 compared to the 1,200 for the. It's a ridiculous price jump, and I think my brother-in-law is going to be super happy with it. Hopefully he is. Um, hopefully he's super happy with it. I think it's a fantastic bang for buck, and it has AV1 encoding. So if you wanted to stream with that bad boy, it'd be pretty good. It'd be better than what I have. So I think I'm just gonna wait until next year. Hopefully the 50 series will get cheaper. I don't know how. Like literally, do no performance, but make it cheaper and consume less power, and I'd buy it. Give me a 4080 that is cheaper and consumes less power. That's all I want. Don't make it faster. Don't do any improvements. I just want a 4080 that's cheaper, smaller, and consumes less power. Nvidia is just making up their numbers for their pricing. That's what I think. Like, I also think that they have a performance issue. I really do, because they made it bigger just because they put more cooling. So like they put a much larger heatsink and bigger fans on it, and the board itself didn't really grow any larger, the PCB. And so I think that they couldn't get the specs they wanted, and so they were really just throwing power at the problem and not actually coming up with an improvement. That's my theory. I'm not an expert on GPUs. That's my theory. That's what I'm saying. A cheaper 4070 or 4080, yeah, 47 with lots of memory would be a great card if it became a 5000 series. That is exactly what I'm saying. Give me a 50 series that just looks to be a cheaper, more power efficient version of the 40 series. I don't need a better graphics card. Nobody really does. Yeah. Yep. Yep. Anyways, I another thing that I'm really happy about with getting this is I hope Intel makes another series of cards, because bang for buck, if they can keep doing this and getting better, I think they're like a serious contender. And I really want serious contenders, because I think part of Nvidia's problem is they haven't had a serious contender until recently, and that's going to force them to be competitive on pricing, because as the A770 is so close to like a 30 series, there's no reason to get a 30 series because the ARC is cheaper. Go Carmine Corp. All right. Yep. Go watch the stuff. Thanks everyone for joining. I will see you guys next